Hello. So good morning, sir. Good morning, guys. So today we are going to solve a problem in R.K Bansal, Bansal, page number 107. Problem number 5.1. Okay. So the topic will be reactions of simply supported beams. Reactions of simply supported beams. Okay. Now, the problem given here is, I will just say, a simply supported beam AB of span 6 meter. So let us draw that figure. Okay. So this is the beam. I'm just drawing the beam A, B, and in that beam we have to find out the reactions in A and B, and there is one 3 kilonewton and 6 kilonewton. Okay, and from A this is given as 2 meter, and from A again this is given as 4 meter. And we know that this total is 6 meter. Fine. We want to find the reactions at A and B. So to find reactions at A and B, so to find out the forces, we can see that there are fundamentally three equations that we use to find out the force equilibrium in a problem. So what are these equations? Let's write it down fundamentally. So that are sigma fx, sigma fy, sigma m, right, should be equal to 0. All should be equal to 0. Let me just write it. Okay? All should be equal to 0. So in this case, in this problem, we can see that there are only forces in y direction, right? If I draw coordinates, this is x, this is y, right? So only mx and my, or only x. There are only two coordinates, x direction and y direction, and there is also only one moment about this, right? Only in 2D we can see that this can rotate like this, right? Only in this plane we can rotate. So in this problem, only f, there is no fx also. There is no, in this problem, there is no forces acting in x direction, right? So we don't have to use this. So we don't have to use this formula. We don't have to use this formula. We cut it out. Also, we have to find sigma fy equal to 0, sigma m equal to 0. Now let's write sigma fy equal to 0. Sigma fy equal to 0 means, if forces are acting in the downward direction, there will be something that is acting in A and B which will oppose this, right? So that summation of these forces will be nullified by effect of this thing, right? A and B. So how can we write that? So we will write in this problem that sigma fy equal to 0 and sigma fy equal to 0, 3 plus 6. What is that 3 plus 6? This is what it is acting, right? 3 kilonewton plus 6 kilonewton should be equal to forces at A and forces at B. Correct? Or forces at A and forces at B should oppose this total force, right? Now this is the first equation. Now another equation that we have is sigma m equal to 0, right? So moment about any point in the system should be equal to 0. Now we will take it at about A. That means the moment created by these two forces, right? How it will be acting? It will be acting like this, right? Now should be equal to the moment created by force at B. If it is acting like this, how should it be acting in B? It should be acting in this direction, correct or not? Should be acting in this direction, right? So let's write that in equation. So sigma m equal to 0 means, what is moment created by 3 kilonewton force? Moment created by 3 kilonewton force is 3 force into length, perpendicular length. This is perpendicular length, right? This is 90 degree. So this force by perpendicular length. So force created by 3 kilonewton is 3 into 2 plus, what is the force moment created by 6 kilonewton force? 6 into this distance. What is that? 4. So 6 into 4 should be equal to, what is the force that should be created by that? What should be the moment that should be created by this force at B? This into this distance. So this plus this should be equal to this, right? So that means RB into 6, right? 6 means this. Implies, from this we can get RB equal to how much? 5 kilonewton. You people just try it, you will get it. Okay, RB equal to 5 kilonewton. So that is first answer. Now we have got this, right? Now how to get RA? We will put RB into this equation, we will get RA, right? So RA equal to 3 plus 6 minus RB, which is equal to 3 plus 6 minus 5, which is equal to 4 kilo, right? Hope you understand. I will upload this paper in the link that is given. Just look at it and try to solve the problem by yourself. Okay, all the best.